So today from OSPA and MRO, after that, we are going to deep dive into learnings from the field. I'm Ashvin. I'm part of Wi-Fi TME team. I mainly work on Wi-Fi solutions and field enablement. So and today we are going to deep dive into learnings from the field. So we know when for the very first time when the Wi-Fi 7 launched, right, MLO was one of the key features of the Wi-Fi 7. So we, in fact, in the last mobility field day, we kind of showed three very interesting demos. One is we showed the spectrum view of STR MLMR, and then we talked about the spectrum view of EMLSR, and then we also talked about preamble puncturing, right? So in this session also, we have two very interesting live demo. One is going to be spectrum view of EMLSR in terms of interference, and another one is a live MS Teams call, right? So and then we will walk you through the day two operations on what kind of benefits when this is going to happen, right? So without a further ado, let me jump into the MLO modes. We have seen this slide multiple times. There are two radio solutions, single radio, multiple radio solution. But what it really matters down to the client is the EMLSR and then the STR-MLMR, right? These are the two modes which is available at the client side. So what is STR-MLMR? It is what is the benefit it is bringing up to the table? It is bringing up, it is giving us the aggregation benefit, right? Where we can concurrent, we can do concurrent TX, RX over the multiple links. In the case of EMLSR, it is bringing us the steering benefits across multiple links. What we see here is the client is going to have the single stream across two chains, and as and when there is a packet downstream to the AP, it kind of indicates through the control frame MURTS, and then both the chain get of the client gets switched into to receiving the two stream data packet, right? And this will bring us the steering benefit. And what we have seen over the period of time is we need to have a proper SSID strategy, right? What happens when you have SSIDs on 2.4, 5 and 6 gigahertz band comparing to having only on 5 and 6, right? So when you have SSID on 2.4 and 5, the client mostly connects in STR-MLMR. And if you have it on 2.4 and 6, it connects it in as an STR-MLMR. But when you have SSIDs on 5 and 6, which is the common deployment practice in the field, where we might tend to have 5 and 6 because we don't wanted to enable it on 2.4, mainly due to 2.4 band will get have a high interference, and it's a polluted channel overall. But what we have noticed is when most of these clients, when you have SSIDs on all three bands, they prefer 2.4 and 6, especially comparing to 2.4 and 5. That's what we have seen. And in last MFT, we kind of presented the client MLO mode selection list. We just added a few more clients, especially Google Pixel 9, iPhone 16, and 16 Pro has come. So we also had added the table for chipset and STR-ML, non-STR-MLMR. What is so interesting on this is when you have SSIDs on all the three bands, as we discussed, it does STR-MLMR. And if you look into the iPhone chart, what it actually, when you have it on 5 and 6 particularly, it is advertising a non-STR-MLMR, okay? But it does not advertise EMLSR. So ultimately what happens is the data transfer would happen only on one link. If you have SSID on 2.4, 5 and 6, it does advertise as the STR-MLMR, but data traffic would always happen in one link, right? So that is the key observation we had, and rest of the observations are actually in line with last data that we published in the last call. Now we will deep dive into the real demo. So in this demo, what we are going to do is we will have a Google Pixel 8 participating in EMLSR mode, and then we will strike the interference on 6 gigahertz band, and then we will see how the client dynamically switch over between two links. So in a high level, this is what our setup would look like. We have our 710p switch connected here and two APs connected to the 710p switch. And then we have an wireless interferer also connected to the same switch. And then we will be doing MLO. So what we see here is we have SSID only on 5 and 6, and this client is connected in both 5 and 6. As you see, the frequency is highlighted as 5 and 6. Now, when I ran a speed test, okay, so okay, so I think the interference is already selected. No, we are seeing an energy here at 6. Maybe you can turn off the interference and we can try it again. Right.
Are you doing demo 2 before demo 1?
Yeah, the demo.
Demo guns are not shining today.
Okay, so I think the interference is already there. That's what the traffic is going here. But the same test, I kind of had a recording of that to be in a safe side. So I'll just walk you through this recording, which is exactly the same because this test we ran it in the morning. So what we see here is I'm just showing you there are like the API radios are there in in all the radios, and then these are all the list of SSIDs. I have it. And in this particular test, I'm going to strike it because it's the recorded one. We are going to strike it at interference on 5 and then see it moving to the 6, right? As you see, we will be first connecting the client. So the client, what we saw is 5 and 6. If you see on the spectrum, the spectrum is completely free on this 5 gigahertz and 6 gigahertz. Right, it is free, and then I'm starting the speed test, and then this time you see the good throughput here, and then what we see is the energy picked up in both 5 and 6, right? So now you focus on that that area of 153 channel space where there is a spike of that. Once we inject the interference here, what we would see shortly is the traffic at 5 will get stopped. So this is the interference strike, right? So you would see the client smartly moves to the 6 gigahertz without disconnect, right? So this is one of the key, right? In the last MFD call, we kind of striked it on the secondary channel, right? And then we showed the benefits of MLO when it was dynamically adjusting the bandwidth and it was sharing. Now we are striking it on the primary channel to see how the client dynamically switch to the other band without any interference. For the legacy system, what it what would happen for the legacy system is basically it kind of disconnect or move to the different channel. So this is a key benefit. That's one of the reason why we need to move on to Wi-Fi 7, take the benefit of MLO feature and start moving on to this, right? So this is this part of the first demo. And then the second demo is even more challenging. So what we are trying to do for the second demo is we are trying to bring the day 2 operations live, right? Now we will have two clients. One is MLO client and then the non-MLO client, both joined to the same access point, right? And then the active Teams call will be going on. When the Teams call is going live, we kind of bring in the interference. We wanted to showcase the Teams call will continue to go on for the MLO and then for the non-MLO clients too. At the end of the call, we kind of give the summary, right? The call quality, that are we having the ability to detect the call live? And then what is the call quality? The call quality on the MLO client will not, because the client would smartly move to the other band, whereas the call which is there for the Wi-Fi, the 6 client, which will deteriorate, and then we should have the ability to detect that and send the live feeds to the administrator, right? So even before somebody actually reports a support ticket, we should be able to see that live, right? So that is the goal of this second call. So what I'm doing is I have three participants here. One is me, Alex. I will be the presenter. What you see my name here, and another client, Alex. I want one of the volunteers to take this Pixel 8 phone, which is an MLO phone. We want you to show your face and see the real time the benefit of MLO. So I'll make the call. And then the next the person would be Bob. Bhupinder would pretend himself as a Bob, and he will also join the same conference call, right? So you can have one of you can have this live. So already you are live. So sorry, Ross.
Throw it out.
Okay,
Give me a smooth look.
Yeah. So what we see is we kind of already had the interference. We were not able to stop the interference, right? The previous demo. So this is the same experiment that we wanted to do live, right? So this also has been taken live. So we have two users, Alex and Bob. And what we are trying to show is both of them are connected. You see an MLO, which is a master MLO link, and then we also have a link view and the master view. And we are bringing in the Teams call. So same, Bhupinder was acting as a Bob here. So, and what we see is he is already there in the call. And then I am there, but with a different dress in my office trying to explore this. And what we see is in the lower side, I am there on the top, and then I'm showing my own face, and then Bhupinder is in the other side. So he is waving his hand, so all good. And we will very shortly induce an interference. And then what we would see is Bhupinder's video will get completely stuck, right? Right. So at this moment, we have already injected the interference. And this is how we wanted to show the spectrum. What you see in this test, it was already operating in channel 5. And then the interference is stuck on the 5, right? So what we actually see is the two clients, there is no impact on the MLO client, whereas there is an impact on the non-MLO, right? That's what we wanted to show.
Oh, okay. Gotcha.
Okay, so remaining.
This is the EMLSR.
This is on the EMLSR, right?
Yeah.
So if I just fast forward a little bit, and there comes a very interesting view from our CVQ, right? Right. So what we are trying to show here is the live feeds, right? So we have the ability to detect a call. As you see, the MLO, the non-MLO client is suffering, but the MLO clients are not, right? And then there is a live feed for an administrator where you get the live there is one client which is actually suffering in this test, right? So we can and this has also been integrated to Slack and other MS Teams and other webhooks. So what we see is a poor application being detected live, and we have also built the Explorer view that clearly calls out, like tells how long the call has been running and things like that, right?
Are you getting the Teams quality info from Teams, or are you looking at?
No, we have our own stuff in. We did trained a lot of package and classified our own algorithm for that.
Okay.
So it's not a Teams integration.
This is not a Teams
So
integration.
when you say I'm looking at the live feed, how do you know like that's the call that both of those devices?
So we have our classification engine.
Mhm.
So that detects what what call it is. If it is Zoom or Teams, we have the classification engine built internal, and then we kind of classify them, right?
Yeah.
So I also mapped this classification of Teams call to an access category of voice, right?
Okay.
So that's where when you saw that video, though the Alex was not which is Google Pixel 9, which was working fine, the Bob, which is acting as Pixel 6, was not disconnected on the call because we are already pushing that into the voice access category.
Yeah, so if we have a group of people who are on a call and you've got the one guy with the device that's not,
Yes.
Wi-Fi 7 and MLO enabled, you're able to go into the dashboard and say, yeah, only these specific people are impacted, but we've got newer devices that are still able to be on that call.
Yes.
And so I can get that information here from that dashboard.
And not only that, when you are actually on the call, when you are suffering badly, you will get a live feed saying this, right? So here you see one client, Bob, faced a Wi-Fi issue that led to the poor application quality at that location. And then these are all the possible root cause of that, right? So in this case, the root causes are 3 because we are running a interference test, which is not practical, which is loading your network for 95%. Yeah. Okay.
You gave this demo previously, which is great, that when you kick in interference, then MLO does its magic. I was wondering, that's a pretty obvious thing. I mean, you're just blasting that channel. In the real world, a lot of times the downside is a channel's busy. What's the trigger to make MLO go? So, I mean, you literally took out a segment of the frequency.
Like under congestion.
Like, does MLO trigger with just congestion? I mean, there's other things that would be where MLO would solve the problem.
So it is, if I hear your questions right, so you wanted to basically the trigger to stop the MLO, is that?
To start.
The trigger to start is, it's all based on the CCA of the individual, the access point on a client. Based on certain threshold, it knows that which channel is free, and then it just kind of move the traffic to the other band.
I guess the question is, will that CCA trigger with just congestion?
Yes.
Or does it have to be?
It is on a per packet. It is on a per packet basis, and then it just see whichever link at that moment is free, and then it kind of send it to the other channel.
Thank you.
Yeah. So so that's all I have for the 2 demos. Sorry, we could not meet the demo gods for not favoring us, but then we kind of covered it with the demo, recorded one. Yeah.
I have a question about the the SDR versus the EML-MR. You said most companies nowadays they deploy on 5 and 6. Right. Is there like a true advantage to start deploying on 2.4 as well to take advantage of the SDR MLMR?
So yes, so it's purely based on the administrator's thing, right? So what we are trying to say is you would certainly get SDR MLMR aggregation benefit. It's not that all the environment in 2.4 is going to be crowded. In our lab, when we measured, what we have seen is even if there is 50 to 70% is bad on 2.4, we would certainly get 10% gain, overall gain, right? So you can decide whether to really use 2.4, but the actual practical deployment, what we see on the field is going to be on 5 and 6, right? So, so in that way, admin has to be aware that, okay, in 5 and 6, this is what the EMLSR can dynamically switch between links, and you should get the benefit of, without disconnecting the client, how I can switch between 2 links. That is a key aspect here.
So it's more about the reliability of the connection.
Reliability and latency of the.
Yeah. Okay.
Yeah.